Alright guys, I'm going to talk to y'all for a little bit about active transport. So active transport is when we are moving molecules across the cell membrane against their concentration gradient. So my solute particles move against the concentration gradient. What that looks like in the picture is one side of your membrane is going to have more solutes. So we call that hypertonic. So there's more solutes on one side than there are on the other. Okay. In regular diffusion, in order to reach homeostasis, these molecules would want to move down here to where there's a lower concentration in order to create balance. Okay, but in active transport, we are going to push them against the way that they want to go. So we're going to move them in the opposite direction. These solute particles are going to be pumped across the membrane against their concentration gradient. Okay, so that would be from low solute concentration to a high solute concentration. Okay, these protein pumps are needed to pump the solutes across the membrane. So protein pumps are needed. Okay, another thing that's needed is because these solute particles are not moving in the direction that they want to go, it actually requires energy in order to move these against their gradient. So the example that we talked about in class and we did some flip notes on was a sodium-potassium pump. Okay, those molecules were being pumped against their gradient, but in order to do that, we needed energy in the form of ATP. Okay, that ATP, the third phosphate in ATP, is going to phosphorylate the protein, and that is going to cause the change in the shape that's going to move the solute particles against their gradient. So I'm going to write phosphorylation. If I can spell that right, who knows? Phosphorylation is going to change the shape. That's how we are able to move those particles across the membrane.